right, with chapter 7, we dive into hypothesis testing. And this is really kind of the crux of the matter for a lot of what statistics is, especially in terms of research. This is the type of statistics, for example, in today's world, that doctors are using to determine whether or not any possible vaccine for coronavirus is working, or if even the tests for coronavirus are working. This is the type of information that they are looking for, and this is the type of test, statistically speaking, that they will be performing and that they are performing to decide what's going on in terms of the validity of what it is that they are trying to create and invent to help the world out. So, kind of from the big picture viewpoint here again, we will be putting the assumptions about a population to the test. Okay, so no saying like, oh, well, I'm pretty sure that it's this, or even based on historical data, we think it's this. The world changes, and we know that. Things change. Life expectancy, for example, 100 years ago was not what it is today. And so we don't make the assumption that life expectancy is still to be 60 years old. We now know, again, because of hypothesis testing and a lot of data, that life expectancy has changed. So we put assumptions, historical things that we think are true, to a test. Okay. So if you remember back in chapter 6, and it kind of sounded weird as we went through, but one of the things we kept saying is that if something is a highly unusual event, so if the probability of that event occurring is really, really low, it may be because an assumption about our population was wrong. So again, think of life expectancy. If we were still operating under the assumption that the life expectancy of people was 60 years old, and we took a random sample of 100 obituaries across the nation on a given day, and we found that the average age that they were dying at was, say, 72, that might lead us to believe that maybe the life expectancy isn't really 60 years old anymore. You would find it very rare, very odd to find a life expectancy with an average age of, say, 72 if it's really truly 60. Okay, so kind of keep that perspective in mind as we go through this next little bit here. All right, so this isn't going to work quite so well in terms of a group discussion, but I do want you to think about this scenario. So if you flipped a coin 10 times and the coin was fair, okay, fair meaning it's equally likely to land heads up as tails up, what would you expect to happen? Okay, and I think most of you would say, well, expected value is the mean, right? It's the average. So I would expect that the coin would land heads up 50% of the time, or about 5 out of 10 times. Okay, however, let's say we flip that coin 10 times and we got 6 heads. Would that say to you that the coin isn't fair? Or would you be like, oh, well, no, like I thought it'd be 5, it was 6, no big deal? That's probably what most of you would think, okay? But what if we went to 10 times? What if we flipped that coin 10 times and we got 10 heads? Would that seem a little suspicious to you? And for most of you, you're probably thinking like, wow, that starts to get a little weird. Could it happen? Absolutely. All right. Is it likely to happen? Maybe not so much. Okay. So then, and again, a little weird without a discussion, but how many heads would there have to be for you personally to start thinking that that coin is not fair? Okay. 6, 7, 8, 9, 10. Where is it that you draw that line and you start to think that something weird is going on? Okay, well, we can't all just have our personal opinion about what makes something weird. So there are some statistical measures that help us determine what is weird or unusual or strange. Okay, so first, some definitions here. Hypothesis testing is making a decision about a parameter based on a statistic. Okay, so remember, a parameter is something that applies to the population. So it could be a mean, It could be a proportion or a percent. That's largely what we deal with, okay? So we're going to make a decision about an average number of something or a percentage of something for the population based on a statistic, the mean or the proportion or percent that we found from our sample. Okay, and if you need to back that up and write some of that down, please do. It's things we've talked about before, but I also know it's things that it takes some people longer to get a grasp on than others. So back it up and listen again if you need to. All right, what is a null hypothesis? Okay, a null hypothesis is a historical value, claim, or specification. And that specification is usually about like a product specification. Like, this package of cookies contains 562 grams of cookies or whatever, but it could be about other things as well, okay? The null hypothesis, another way to think of this is the assumption that is being made. Okay, this is the assumption that we are making, again, based on something that has happened in the past or something that maybe it says on the package or because somebody said something at a press conference. That's the claim. And then we're going to test whether or not that is true. The symbol for the null hypothesis is a capital H with a subscript 0. Okay, it said H naught or H sub 0 if you want. 0 meaning the beginning point. Okay, so this is our starting point, our null hypothesis. The alternative hypothesis is what we want to prove. Okay, this is what we're trying to find out. So let's say we hear a claim on TV. Somebody says, hey, the percentage of people who believe that alien life forms inhabit the universe is whatever, and then we think that it's higher than that. And so we're going to set out to prove that it's higher than that, okay? The symbol for the alternative hypothesis is H with a subscript A for the alternative hypothesis. Occasionally, depending on your textbook or whatever, you will also see an H sub 1. The H sub A is the one that we will use. Okay, however, I've taught in many books where they do use the H sub 1. And so if you take another stats class, maybe a stats for whatever your major is, social work, criminal justice, nursing, you may see that, that notation instead. Okay, so what do we do hypothesis testing for? Well, we can do hypothesis testing for the population proportion, which is the symbol P, or we can do hypothesis testing for the population mean, which is the symbol mu. And what we're going to start looking at in the next several lessons, actually the next two chapters, chapter 7 and 8, is how we actually go about doing these tests.